Hi everybody. Today we're going to discuss logistic regression. So, what is logistic regression? It's used to estimate the probability of an event occurring, such as voted or didn't vote, based on a given type of data with independent and dependent variables. So, it's a data analysis technique that uses mathematical methods to find relationships between two given data factors. Then it uses that relationship to predict the value of the factors based on the other. So the prediction is usually in terms of finite outcomes like yes or no. In this data set here, we are given brand, product, shopping, and loyalty. So the question here asks, um, the table here gives the data for 30 more respondents. Loyalty column indicates whether the customer is brand loyal. Brand column indicates if the attitude towards the brand. Product column indicates the attitude towards the product category, and shopping column indicates his attitude towards shopping. All columns are on a 7-point scale, 1 being unfavorable and 7 being very favorable. Estimate the probability of a customer based on these three inputs. Calculate whether the customer would be loyal or not if his loyalty, brand, and shopping scores are 4, 6, and 2 respectively. So let's just add these values in 4, 6, and 2. So this is the part that represents the new customer, and we're basically trying to find if this customer is loyal or not based on this existing data provided for us. So the first thing we do is calculate the Z-score. How to calculate the Z-score? So basically, in order to establish a relationship between two variables, you need to find the coefficient, which is basically the degree to which one variable is dependent on the other variable. And here, we're just going to call our coefficients beta naught, beta 1, beta 2, and beta 3. So since we have three different variables here, brand, product, and shopping, we have beta 1, beta 2, beta 3, and beta naught is basically a constant. So I'm going to take arbitrary numbers here. So that is 0.25. And I'll just assume that all of these are 0.25. We will later find the actual value upon using solver later in the video. So for now, my Z-score is equal to beta naught plus some product. Some product basically just multiplies each one of these cells with the cells down here with its own coefficient. Some product of these three values, comma, these three values right here. And we're just going to log these because these have to remain constant. You can do that by using F4 and enter. And now just drag this down. And you can apply it to this cell over here as well for the prediction. Then after Z-score, we find the p-value. P-value is basically the probability of the individual being loyal, and 1 minus p is the probability of the individual not being loyal. So p-values formula is open parentheses after your equal sign, exp, which is basically just the opposite of a log function. Select the Z-score divided by open parentheses 1 plus exp again, and select the same score or same cell e2 and close brackets. Now drag this value down with here, and then is equal to 1 minus p for 1 minus p, 1 minus the value that is in the cell, enter. And drag that down as well. After that, we find the likelihood. So the formula for likelihood is we have to use an if function here. If the loyalty is equal to 1, is equal to 1, then the value to be displayed here is the p-value. Because it says 1, that's a positive response, and the likelihood of a positive response is represented here. And if it does not say 1, then the false value is displayed. which is 1 minus B. So that and enter and drop that down. After likelihood, we have to find the log of likelihood, which is just very simple. It's equal to ln, open brackets, click on that, enter. So, and the last thing left is prediction. Now, okay, now to find the prediction, we need to find the actual beta 1, beta 2, beta 3 value. In order to do that, first, let's find the sum of log of likelihood. And I'll write it down right here is equal to sum and all these values, close the bracket. Right. Now, what we're going to do here is go to solver, select the objective. The objective would be the sum of log of likelihood. And obviously, we would want the likelihood to be maximized because we want more people to be loyal. So select maximize over here. And by changing variables, just select all of these variables. Actually, select one variable, comma 2, comma 3, comma 4, like that. Remove this box and click on solve. Okay. Okay, once we hit solve, we found a new value for sum of log, and a lot of the values on the sheet here have also changed. And these are the new beta values. So these are the accurate coefficients for the relationship between brand, product, shopping, and loyalty. So our predictions formula is if, open parentheses, the p-value is greater than 0.5, comma, 1, comma, 0. As in, if the p-value is greater than 0.5, it's represented by 1, which means there's a positive response and that person is going to stay loyal to the brand. And if the p-value is less than 0.5, then it's represented by a 0, which means the person is probably not going to stay with the brand. Enter. And drag that down. So according to this prediction over here, the person who scored 4 for brand, 6 for product, and 2 for shopping, this person is not going to be loyal to the brand. And that is how we use logistic regression. Thank you.